Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 37. In today's lesson, we're going to be continuing our refactoring and our testing. So where we left off last time, we did a little bit of refactoring here for our queues, might turn them in the registration windows. My other thought was maybe these should be a registration area that has the windows, but before we get there, we need to do some testing over here. So that's what we're going to start today. Yeah, there's even my comment. So we'll begin here. So just go ahead and get started. So this is a model. So let's make a model test class here. A registration window tests. All right, I'm going to right click this one and I'm going to send it right. Not there. New vertical. All right. So we're going to start making this public. All right. So what makes a registration window? Basically, the data structure is a key. So it has some information as an index. We're just setting that index though. There's on creation. It doesn't change once it's set. So I don't really see a lot of value there. Count. We should make sure the count's right. It's going to be though because of that. But we could do a really quick test. So there was two things you could do: a fact, public void. So you could do a fact, and that's one that's void and doesn't take any information. Or you could do a theory, and that's one that does take information. So here we'll do int count. And then we'll do inline data. So when you're doing, so I mentioned it's called boundary and value analysis, and what we could do here is since count's an integer here, you as well. Yeah. So since it's all integers, we have some value ranges. So we can't really pass in a negative number. So we should see what happens if we, for the count here, we don't need to. Instead, let's do, we'll do a 0, copy. So 1, copy. Now let's do something larger. So 0, 1, or many is what you want to do here. So I'm going to say int.max value. And we'll do one more. There we go. There's my values. And let's see. We'll see what negative does as well, just because I'm curious, but I don't think it matters. Oh, we can also do this, by the way. C#, this is perfectly valid. See there, it even knows it's the same thing. So you can have -0, but it doesn't really change anything. It's still 0. Let's write us a test. Let me put up my headphones just a second. Okay, let's write a test. So this is easy. So we'll create a var system under test equals. Let's do it as this. Let's do registration window system under test equals new. We'll pass in a 1 for an index. So we'll hit this, control enter or control dot. We'll create our using statement. So now we can do assert equals so 0 so count. So we expect it to start at 0. Then we'll do our we probably don't want to do that's gonna break our pattern. Let's not do that for now, but say assert backwards. Wait, this is a range. Assert. I'm going to say that was valid. Actually, let's do assert.count. Assert our precondition. So here I'm going to say that's the precondition of where we're starting. So we're saying for all these tests, we're starting at the precondition. So act here, we need to set up our queue for situation. We'll do slip.enqueue new registrant. ID equals 0. ID new event type dot arrival date time. So I don't care about the date time, so we'll just do now. ID equals ID. There we go. Got us for enqueuing a value. We need to do that a couple times. So what we can do here is for I equals 0, I less than count, I plus. So on the end of this, we expect this to match our initial count. So there's just a test. We'll see if that works. One thing I do want to do is print the ID plus. Yeah, I think that'll be sufficient. So as we're going through, we'll start at ID 0 and we'll just add up the IDs, even though I don't think it'll matter. And at the end, we just assert. So let's see what happens if we run the test. But I guess I was expecting there to be some way to run the test here, but I guess we'll go to models and run it here. Let's see what we get. The one I think might not work is the negative. First build is taking an awful long time. Is that what it's doing? Says it's ready, but an awful long time on this. It's looping through the list 2 billion times, so maybe that's it. So maybe we'll have to turn down that number. It doesn't take that long to loop through. Let's stop that. Let's see if this one runs. Okay, yeah, so that is what it's doing. Let's adjust that. So here, see if the negative one fails. That's good. All right, so we can add -1. Yeah, because the count's less. So we'll deal with that one as a separate case. Let's speed this up just a little bit. We don't actually need to care about ID or anything. I was just doing it to keep it a little more real. Let's pull this out. Let's do var registrant equals that. Now ID doesn't matter. Now we'll just add the same registrant over and over. Get rid of ID there. Get rid of that. Add one more of these here. All right, now let's see about the. Shouldn't take that long to run through 2 billion loops, but I'm afraid it's keeping having to extend the queue, so it's taking for. Yeah, let's trying to think. Maybe we should adapt to add a next array dimensions. If this one would actually run, if that would put it on it. Oh, array dimensions. Interesting. So it's trying to double the capacity. So let's make an adjustment here. So we'll add a new parameter to the class. Let's do int capacity. Now we can pass in a capacity, and we'll say normally it equals 10. Give us a default value so we don't always have to do that. But here we can set a value here to the count. That way it won't resize. Let's see if this is a little faster. Significantly faster, but we're too large. Interesting. Let's see. Oh, let's look up Q and let's see the constructor. If I look online, let's see how big it can. Docs don't really say. I'm a little surprised that doesn't work then. At 32 capacity. Let's try one more. Let's do -2 there. Okay, this one seems to be running. I think. Let's run aboard. No. Out of memory exception. That one's surprising to me. So I'm guessing that it can't support that many values. Try something. Try 2 divided by 2. Figure out what the limit is. Okay, that one seems to be working. Oh no, it stopped again. There we go. All right, let's check something here. Let's do a assert 0 assert dot equal 0 size of registrant. Okay. What I'm assuming is that it's saying that it's too large for whatever memory I can allocate it that. So how it's doing each array, so that's 2 billion cells. Let's see, let's pull up calculator. Let's see. 147 483 647. All right, so we have that number. Let's multiply by, if it was just a memory pointer, there would be 8 bytes of it. That's as small as they could possibly be. So we'll say that. Right, so let's say roughly 1,000. So bytes, kilobytes, megabytes, 17 gigs. Is that right? Seems awful big. I may not be doing that right. Yeah, that doesn't sound right. And I'll have to think on that. But either way, we're not going to be able to do as big a one as we want. So let's see. Minus, let's do minus 1,000. Let's see. I actually don't know what the limit is here. I thought the docs might. What I think is happening is it's trying to allocate the array. I think it's only be able to hold so much space. Should be able to check that. I wonder. Duration. You made any change? Yeah, I don't know where I'm gonna find the setting I want. Now let's. Nope, still failed. All right, so there's some limit there. It looks to me that it should be able to support or up to int max, but that's clearly not what's happening. Go back over here, so go to the properties. So what I tried to do is put it on a so it'd run 64 bit rather than 32-bit, but that doesn't seem to be the case. I was thinking maybe there's a 4 gigabyte memory limit and putting the registrants on whatever size they end up being bigger than that, but that does not seem to be the case. But either way, so we'll say our boundary, I was going to try to do just int max because that could make sense. We'll say it's very we'll say it's unlikely to be over 1,000. So let's use 1,000 as the upper limit. Maybe we'll have to enforce that because 1,000 people in line for a registration, you're not going to finish that day anyway. Maybe that's actually would be a good one. So to do that, we would add to the enqueue here and do some kind of check for the count. Yeah, let's do that. That'll at least give us a different option as well. So let's say 1,000. Let's say we've got a business reason to do say that 1,000. We'll do it as a constant. Const int max number in line equals 1,000. So we'll say that's a hard limit. So if count plus or if count plus 1 is greater than max number in line, throw new exception. Too many people in line. We'll throw, let's say it's an invalid operation exception. All right. So now we can test that case. So now we have a hard limit of 1,000. That would be called a business logic. So our business logic says that there's some limit there, and the limit's 1,000 for us. Now we do need to test that case for sure, but we'll test it in the enqueue method of the count. So count there. So let's do that. So we'll say fact public void. Let's change it. Let's do count is valid when between 0 and 1,000 registrants are added. There we go. There's a little better name, so let's do that here as well. So we'll say enqueue throws invalid operation exception when there are over 1,000 registrants. So we'll copy our setup here, but like this. Count here is 1,001. So here we'll do the first 1,000. All right, so how we do this, we'll say exception e equals assert dot throws invalid operation. Then we'll put it in the lambda there like that. So lambda enqueue registrant. That's the 1,000th registrant. And now we can say e dot, let's see, e dot message. That one's hard because the assert there is both an assert, it's asserting that it throws, and it's actually doing the logic. So a little tricky there. So what we could do there is to actually do action a equals assert dot enqueue registrant there, and now we can just call the action here. Now that's firmly into the assert category. So there, we followed our pattern, but I would argue that the other one is perfectly fine. Like I said, in reality, once we get a little further in, I'll stop using the range asserts and just assume that they're even suggesting to use the local function. Interesting. That is not the change I would have thought, actually. Take that. So instead of an action, do a local function. I guess that works too. That's not the way I would have thought of doing it, but that works. I'm not sure if I don't like the other one better, but again, that's what I know. So we'll keep it like this. Let's see what happens. So now we have the little pop-up here, the little code lens. Hey, strings differ. Oh. Strings differed because I didn't write a string. Too many people in line. Now let's see if they. There we made sure their test does or can fail, and there it's successful. So there we go. We'll do this. So I'm saying this is a count because counts how we're actually testing it. reality, this is testing in queue. In queue successfully adds registrants when below the 1,000 limit. See, and logically, I can't think of a way to actually enqueue a negative number of people, so we'll test that on the dequeue. So if we imagine though, so now this method, it tests the good case, so valid, it tests this case. This one tests the bad case, it throws, and then we're testing count through that one. So let's look at dequeue. So we'll say fact public void dequeue returns a registrant and decreases the count. So right there might be a questionable decision. So a lot of times if you have an and like that, that's a sign you probably should make this into two separate tests. So we'll make it first and then we'll think about that. So arrange, act, assert. So we'll do same as before, registration window, under test equals new, 0. We'll leave the capacity. I'm not going to get high. Christian, where do we use index? 0 references. We use index inside. What is this? I don't think we need that. Delete that, see what we break. Broke something. Could see a player, I can tell you what. It's over here. Alright, so that's sort of alright, but let's go check over here. Don't need to add that. Let's see the other use. Okay, that's the only real use. There we go. So there we just did a refactor. So a refactor there makes this, so we no longer want that there. So by refactoring, now we just have one optional parameter, and we got rid of an index, which I don't think, no. I don't remember what I had in mind for that. I didn't write it out. We'll assume that was all right. Back here, so we got a system under test. So let's copy registrant here. These are probably as well. Yeah, this is probably set up as well. So our only action's actually that one, the one that actually fails. Same thing here. That one's not. This one the action's the failure case. This one the action's the case. That one's actually alright. But let's see. We were copying this one. Add that here. So our action here, soot.enqueue registrant, is not the action. The action is var output equal, let's say actual. So a lot of times with testing, you'll have expected and actual. If you look here at the assert equals expected and actual, you notice they're actually using those values there. We'll say, let's set the ID to something better. Let's say ID is 42. We'll do a constant up here, const int expected ID equals 42. Do it like that. So now we'll have expected ID equals actual dot registration ID. Make sure it's the right device, and now we should check the count equals 0, then soot.count. So that's our conditions, what we expect it to be on the outside, the outset of this. So let's see what happens. So we expect to be able to get their registrant with the expected ID and the account to be 0. There we go. So again, I said and can be bad here. So we have two asserts here. So we could separate this out into two tests very easily, but a lot of times when they're in a property, a lot of times I find them just as easy to test here. Now, if we're having different outcomes because we're running different methods, that's when I start seeing it better to separate it. But when we have it like that, I tend to have more trouble saying that probably don't. So let's see. So let's make sure it works in the case where there's multiple values. Multiple, say, registrants. All right, so let's do our for loop up here. Now we can grab that. Let's look at a feature instead. So if we select this and do a right click, if there's not a snippet, surround with, so that lets you surround a block of code with another code. I don't know why there's a 4 with 2 R's. Let's just click it and see what happens. Decrementing. Okay. Not how long we're going to think about it, so we'll increment. There we go. It surrounded our block there, and now we can say 1000. Let's do a const int max count equals 1000. Max count. Now we added 1000. Now we decrement. Now our thing equals max count minus 1. And in this case, we don't care about the ID because the IDs are all the same. So we are more worried about the count. And there we no longer care about the actual value we're getting back from that. So we can use a discard variable. So if you see an underscore like that, that just means you're dropping whatever it comes out. And that's just a way to programmatically say, don't worry about it. Let's see if this works. We should see 99 here at the end. We do. Good. Now, let's do one more. Another DQ test. And here we might need to make an adjustment over here. So let's see. So I think it'll throws when there are no registrants. I believe this will throw an exception. Let's see what happens. So here we do that. Here we do that. So I think this void a if this what was the syntax for that? Okay, that makes sense. So okay, so the syntax is okay, so it is just a local function. So one we're not putting in at the end. So we're putting a there, so I think this will exception e equals assert dot throws exception a e dot message e no assert dot equals e dot message. I expect this to fail, but let's just see what happens. All right, no registrants. Exception not in an exact match. All right, but that seems like a decent message. So queue empty. So valid operation exit. This one will pass, but again, I think we want to make an adjustment. Queue empty. Let's put it in the error context. So again, looking at this from an error from our business logic side, it's a registrant instead of a queue. So let's just catch that. So if count equals 0, let's do it less than 1. If count is less than 1, throw new invalid operation exception. Registration window is empty. And we'll grab that. We just wrote it. We know it's going to work here. So here we go. Yep, there we go. There's just another test. I think that's a decent test. All right, so now let's do the peek method. The peek method here's easy, right? I'll make sure it's easy. So we could clean this up. We could do this exactly the same up here. We could move this as the return value, and then we can make it into a ternary as well. We're going to keep it separate, but separate because peek doesn't actually throw. I'd rather keep the throw separate. So let's do a fact public void peek returns registrant without removing when there is one. So when there's one registrant, returns first registrant. So when there's just one. So let's copy this, I guess. Copy this, so we'll do peek here instead. Now there's one. So it can be null. So let's do a check here. Assert dot not null. actual. There we go. There's just another check. So I think this will work as is. See what happens. So we get one. Count should be 1 though, so test should fail. Okay, and it paused. So count should still be 1. In fact, let's add this. So add a comment there, and then post condition count is still 1. Now let's see this one run. Good. So there. So we added a precondition and a post condition to running peak. All right, let's try that again. So let's say do that, but with more numbers. So I'm perfectly fine with using 1,000 still. And max count equals 1,000. We'll do a not that. Right click. Look at that. Control dot. Yeah. Okay, right. Select it, right click, and snip it. Control K, Control S. Let's try that. Control K, Control S. 4. There we go. 4 max. And notice it messed the insert. Equals max count. Count. Let's do this. Let's do -1. So we'll do the first one here is a special one. Copy this. Expected ID -1, -1, -1. So make sure we got the correct person. There we go. So we make sure peak's actually working there. So let's take this one a little further. So let's go ahead and remove one now. Sup.deque. So remove the first one. Now actual equals sup.peak again. Now all these values should change ever so slightly. Now we expect it to be expected value. Count -1. There's just a much bigger test with a lot more checks, but I think it's actually doing what we want to. So there we're making sure peak works in multiple conditions. Now let's do one more peak. This one, peak returns null when there are no registrants. I accidentally got rid of my system under test. Peak. Now we're going to say it is null. Null. So there's no value here, so we can't check that. But the value should still be 0. Now, if we run this test, should see the green. There we go. There's just a peak method. All right, registration numbers. So what we're getting here is just a listing of registration numbers that are added. So again, the conditions are 0, 1, and many. We'll do fact public void registrant numbers return no values when there are no registrants. All right, so let's do range act assert registration window assert equals new var actual equals assert dot registration numbers dot to array method. We get the list there. So now let's say assert dot empty actual. So we'll say actual is empty. Like to see a green test. A green test. Yes, there we go. So there's this one green one. So let's do it again, but let's say returns a single registrant, and there is just one registrant. Grab the creation logic here. Yes, I noticed that there's an extra. There we go. Assert.enqueue registrant. There we go. So now, if there's an assert.single, I think there is. Assert.single. So that says there's one value in the enumerable. In fact, we don't even need to do an array in that. I don't guess we need to in this one either. Let's make sure this one still works. Yes. And yes, good. So single just does exactly what it says. It verifies that a collection contains only one item. So let's expand this again. Our many registrants. There we go. We'll do the same thing here. We will do a Control K, Control S, surround with a 4, do a const int max count equals 1000. Max count, so add 1000. Assert dot action dot and I don't know how to use that one. Let's see. I thought there was a has count. I don't see. So instead, let's just do equals max count actual dot count. So let's see what the problem is. Cannot convert from method group to... So because this is an enumerable, we need to use the count method. So here we'll say that there's 1,000 there. So let's do something else here. Let's say assert equal expected ID. There we go. We're going to say the first value in that list. So there's how you can do that. I don't think you can actually do an index for an enumerable. No. But you can say dot first. The dot first we haven't really talked about before, but it does exactly what it says. It turns the first element of a sequence. And it comes from something called link, L-I-N-Q here. You've noticed in Visual Studio, it's probably been adding those. I've been deleting a lot of them a lot of time like that, control dot and remove unnecessary using. You can see links now required, and it's because of this dot first. So that's just grabbing the first value from the list, making sure it's equal. So the other way to do that, and how Mike could do it, is do a dot to array or to list. And then you can use the method because now it's a list instead of a count. Now we could do that, grab the first value like we're used to. And that will also work. The other way is actually using the enumerable though, so I'm going to switch back to it. And we're going to note that we may be stepping into link in the near future. So there we go though. So now if I go here, I should be able to see all the tests run. And some of them have their little code lenses here, so you can see there's some testing for it. Yeah, there they just updated. Just took it a little while to update. So there we go. So now we have tested a registration window. So I think that's a pretty good stopping point. We're out of time. So that brings us right up to the convention center though. So we look up the current document, look up to do, performance. Here we go. So that'll be the next lesson. Lesson will be the work on encapsulating this. And we'll write some tests as we go, hopefully. So we'll go ahead and call it there then. So this has been episode 37 of Programming with Shadow. So we'll call it there. So thanks for watching and have a wonderful day.